And the next speaker will be John Snelson. So, John, are you ready? Not yet. It looks cool. So, if you would like to use the one.
Yeah, I don't know, maybe yes.
So we should be on there. Okay. Great. Well, I wanted to come and talk about a new feature that we've been developing for MarkLogic 9. So maybe I should introduce myself. My name's John Snelson. I'm a principal engineer at MarkLogic. If you've been coming to the conference for a while, you may know me as a guy that does lots of XQuery. If you have known me more recently, you might know me as the guy that's also done Sparkle and RDF support in MarkLogic. And my kind of new remit for MarkLogic 9 has included those things and even more stuff, which I'd like to talk about some of that today. But before I really get into what this feature is, in order to kind of explain the benefits of it, I wanted to take a look at some different data models, which I know most of us will be familiar with when we're using databases, and look at some of the benefits and some of the downsides of using those data models. So you might be familiar with the entity relationship model. Usually this is the kind of thing that you start using when you start designing the information model for your database. And so you might draw pretty diagrams like this one. And there'll be relationships, and there'll be entities. And you can see also in the red kind of circles, those entities have properties. In terms of, I mean, it's quite a high-level thing, and no database really supports entity relationship models in this way, but it's a good way to start thinking about your data and your model. And I think one of the reasons why that is because the entities at that level, you can really engage with them as something that makes sense to a human, to you or to your customers or to your business processes in some way. And in that sense, we're really getting to the heart of what information is for, at least as far as I'm concerned, which is in some way to enrich and advance what a human can do. There's all sorts of things we can do to make machines understand data, but at the end of the day, a human also has to understand the information at some point as well. And so it's quite a human process to define what these entities are. What the relationships between them are. In that way, I guess I'd like to start by suggesting that maybe the entity relationship diagrams are quite a natural data model, and that what we produce after the entity relationship models becomes progressively less natural and more oriented towards the machine and the particular ways that the machine is going to use that data. I tried to look for some material to support my hypothesis that entity relationships was actually a very natural way of describing data. And I didn't come up with any, amazing studies, unfortunately, that I could quote to you, but I will give you the example, which I think has been very successful, obviously, which is the example of hypertext on the internet. And we have this amazing information available to us now, which is all designed around the idea of having documents which describe in some way, some aspect of the information, but then also links from those documents to other documents on the net that will, give further information or related information in some way. And obviously that scales out, as we've seen, and then that can encode a huge amount of knowledge using, what is a very similar technique to entity relationships that we just looked at. And then moving on to, I'm sure, what is the most dominant data model in databases, which is the relational model. I'm sure most of you are familiar with this. The relational model has a mathematical foundation. It's designed the way it is in order to focus on queryability of the data and potentially also reuse of that data. So it does have a machine focus to the way it's been designed. It finds it very difficult to describe certain things. I'm not saying impossible, but it's certainly harder to describe things like hierarchy and sequences and a sparse data model using the relational model. And those things are actually often found in real life. I think it's unlikely that all of the properties of an entity that you want to describe are key values. I think that often there's hierarchy and often there's sequences involved there. Some practical realities when you're actually using RDBMSs. Schema changes are hard. They often involve downtime for the database. And so that makes the model less flexible as you're working with it. When you take your initial entity relationship diagram and you move it into a relational model and you start targeting that as your model, you need to go through a process of normalization. And often what that means is that the natural entities that you've defined need to be split apart into more artificial entities because you only have a row available to you. And so if you need to model a sequence, you need to have a separate table for that sequence, with foreign key relationships to the original row. Or if you need hierarchy, again, you need separate tables with references back to the original row for that entity. And so the entity no longer is a single conceptual thing. It's been split apart into multiple rows in multiple tables. And that process of splitting it apart, it makes the data model harder to understand from the conceptual level, from the higher level. For a human coming to a relational model, it can often be a little bit bewildering as to where the actual entities are and what these auxiliary tables mean. Often when you put data into a relational model, you'll use an ETL process. You'll do extract, transform, and load. And some of the problem there, you're required to do that because the entities are split across multiple tables. But also, implicit in that is the extract part, because what will happen is that often you'll lose full fidelity of the original data. Some of it won't fit in the model that you've created, and you'll end up taking pieces of your original data, populating the tables, and losing some of the original data. At least you'll lose the original structure of the data. But on the flip side, this is the dominant model, and I doubt there's very many of us that haven't had to work with a relational database. And in the practical reality is that there are still people very familiar with a relational model, and that's their go-to way of interacting with a database. Maybe that's the only way they will use to interact with a database. A particular case that's important to us as a company is the case of business analysts. These are people who aren't programmers, but they are tasked with accessing the data and with querying the data, and they overwhelmingly understand how to use SQL or how to use tools to use SQL to look at the data. It's an important part of many businesses, and it's very difficult to try and tell them that they need to use some other technology or some other way of querying. So it does have massive mind share, and that's hard to get away from. That's the slide that I should have had up when I was talking about business analysts. So another data model is the RDF model, in which everything is modeled as a relationship. So it uses triples, where there is a subject, a predicate, and an object. And these very small pieces of data, these very small triples, can be used to describe a whole range of information. It does have hierarchy because it's a graph, and you can use it in that way. Its sparse data is designed in from the very start. However, there are no sequences, or rather, there are things called RDF lists, and they're very unwieldy to use and nearly impossible to query properly. So sequences is a downside. It's hard to get that. Schema changes are easy in RDF, mostly because of the way it was designed. One of the design principles was that anybody can say anything about anything. And that means that if you don't have something in the data already and you find some more information that you want to add to the data, it's very easy to do that. Just add more triples. There's nothing more to it than that. So it does have that going for it. I like to describe the RDF model as being super normalized. I kind of feel like if you got a normalization freak and you put them towards data and you told them to carry on normalizing until there was no more normalizing to do, then you would end up with something like RDF. Because it's split apart so much, every little tiny piece of information is in a separate triple. And that does have that does bring real problems in terms of queryability. There's enormous flexibility, but every query requires a huge number of joins to piece that information that's been split apart back together again. And joins are one of the hard problems when you're querying. They're one of those things that you work very hard to avoid or to minimize the cost of. And then clearly, because I work for MarkLogic and also because I'm at an XML conference, my favorite would be the document model. And here I'm talking about XML, but you should also understand that I'm talking about JSON as well. There are big differences, but compared to the relational model, they're really very similar as a document model in databases. So they do support hierarchy and sequences and sparse data, so they do have all of those things going for them. Although, obviously you can write a schema or an X definition, in fact, for an XML document, you can also use them in a schemaless way, which means that adding information to them can be left very flexible. You can easily add more information to new documents or to update documents in that way. So the thing I'd like about documents is that often a document has been written from a human perspective first. By its definition, when we're talking about markup, we're talking about, getting a page of human language, text, paragraphs, and then saying where the information is, telling the computer, marking up this paragraph, this title. That's the origin of this. And so very often we're back to what I said was, I thought, good about the entity relationship model, which is that it is human-focused. And these pieces of information, these documents, are designed for consumption by humans. So in that way, I think that documents in a document database are very close to the entity relationship model. But obviously, they fulfill the entity side of things. They don't fulfill the relationship side of things. Now, I'm sure many of you would say to me, well, you can have links in documents, look at href, or look at xlink, and specs are available to provide linking between documents. There's no doubt about that, but there's no one way to do it. Even if we'd all like xlink to be that way, we have to admit that people do it in different ways at different times. And so that can be a problem. When you need to model that, you need to also define, well, how am I providing these links and how do I navigate these links? So a question I'd like to answer in the fullness of the talk is how can we consolidate those ways of linking between documents and get closer to something which looks like the entity relationship model that I talked about at the start. So my project for MarkLogic 9, which is still currently ongoing, is to be the technical lead for a project which incorporates all these things on the diagram you can see right now. Including SQL querying and Sparkle querying and then something else called the Optic API. But what I really want to focus on today is this thing called templates, which are also, we're calling them lenses over the data just as a way of describing what they do. But they are a way of writing a description to say, when you see a document that looks like this, you can interpret these places, these values, as a row in a table. So for instance, here you can see what a document, and then the template that defines where to look in that document to produce the values for the columns of a row, and that row then becomes part of a table that can be queried with either SQL or the Optic API is a fascinating thing which I'm not going to talk about very much, but you can see a little snippet of the Optic API code there underneath the SQL on the screen. In addition to pulling out rows, you can do exactly the same to pull out triples from a document. So in the same way, you'd write a template to say, well, here's where you find the subject and the predicate and the object for that triple in that document. And then that triple becomes available to Sparkle queries. The templates, the astute amongst you might be asking some questions like, well, why are you defining a new language to do this when we have XSLT? There are some good reasons for that. This has some similarities to XSLT, but is extremely cut down in terms of what it's capable of. And the reason for that is because these templates actually execute whilst the document's being indexed on its way into the database, which is actually a fairly fundamental difference. So as soon as the document hits the database, the rows are available and the triples are available that are defined in these templates. So they're cut down in what they can do in order to get the performance that we need to be able to execute those whilst we're indexing the documents. A little kind of geek out, because this is my area. We're actually, those of you who know the product know that we've stored triples in MarkLogic for a long time, and we're actually storing the rows as triples as well. And the way that we do that is by saying, well, the row ID from a given row and column is the subject, and the column ID is the predicate, and then there's a value for that kind of cell in the table. And here's an architecture diagram of just what we've been changing, really. We've got this common core which does the querying, does the joins, does the aggregation, and on top of that, we've built SQL. We had Sparkle already, and we've also built this API called the Optic API. Just as a little tidbit, I mean, the thing I like about the Optic API is that it can query the triples and the rows and the documents and do joins across all of those things combined. So that's one of the things that's unique about the way that we've combined these architectures together over the same core capabilities. But I'd like to do a demo to show you a little bit more concretely what templates do and how they work. You may have to bear with me because I think I might have to change the screen so I can see the demo at the same time. Oh, wow. Okay. How visible is that? That's not bad. So we're going to insert a document first, but just to show you what the document looks like. There's some full text information in there. But there's also some structured data in there as well. So we'll just put that into the database. And then we can insert a template. And the template mostly uses XPath to define where to look for things. So first is a context, which looks very much like an XSLT pattern match. In order to qualify to match against a particular document, that context has to match, has to actually return a node. And then you can define one or more rows. Rows can kind of be dependent on each other, so you can do some fancy things there, but this is a simple one. It's defining a table with a schema name and a view name. And then the columns. Here we have just a plain string, and then the type that we're going to coerce that value into. But this one's the interesting one. Although it doesn't look different to name, that's actually an XPath. So that could be an arbitrarily complex XPath. It could be, it could do concatenation, addition, or whatever. But right now, that's just selecting a value from the document. And then there's a definition for each of the other columns in this table. So document, date, league, etc. If I go ahead and I add that template into the MarkLogic schemas database, that will go ahead and cause the document that I put in previously to be indexed again, and the rows will be extracted from that. Now, we implicitly defined a table by inserting that template. And this is the definition of that table. So if we ask the system what that table is, this is what it knows about it, and this is the columns that it knows it has, and the types that they have, and whether they're nullable or not, and things like that. But then we can run a very simple SQL query. So select star from matches, and we'll get back the one row from that table that the template extracted. Now, some of the power of this comes from potentially being able to have different types of documents contribute to the same view. So here is another type of document. The difference about this document, that data that we pulled out before is now inside a meta element, and the ID that we had is in an attribute. It's not in an element. And I'm sure you have had times when you've had to deal with different data, different formats, or formats that documents that people have formatted wrongly. So if we add that document to the database, we can go and look at the table again, but it won't appear in the table because it's the wrong format. But we can insert a second template that now accesses the attribute for the ID. And what happened was the old template said go and look in an element for the ID, and when that wasn't found, then the template was considered to not match that document, and the row didn't get added. But with this new template, once we've added it, it will re-index that old document that we looked at, the second document, and we will see it turn up in the table. So there it is. So now we've got a consolidated view over those different formats. I want to show you how to do triples as well. Here's an example. So probably the only other feature that kind of extends the power of templates is that you can declare these variables up the top. And that is an XPath expression there. It's just a string, but you could make that more complex. So you could pre-calculate values and then use them in multiple triples, or use them in multiple columns in some way. So you can see down here, this variable is being used as the kind of namespace prefix for this IRI that we're creating. So if we add, this is targeted at the, as you can see up here, this is targeted at the document which has the ID element. But if we add that, then we can run a simple Sparkle query. And that Sparkle query returns the triples that we've extracted from that document as well. So it works very similarly. And you can have an RDF view of your documents using this as well. So I want to get to the point where I can tell you what I think are some of the benefits here, because that's one of the main reasons for this. So I need to move on fast. So one of those benefits is if you can have multiple views over the same one source information. Okay? You have happy business analysts because they've got a SQL view of your data. You can have happy ontologists because they've got an RDF view of your data. You still have one place to update, and when you update that one document, every other view that's dependent on that gets updated as well. You have one database, it's transactional, it does do backups in your replication, as opposed to the alternative, which would be using multiple databases where transactions become an issue, backups become really problematic, at least having a consistent backup across all of them, and replication you have to repeat for every single database that you're using. On the flip side, you can have multiple source documents and one view. And so you can combine different data sources in different ways, but still have a single view over all of those data sources. Now, one specific use for this, for instance, I talked about the problem of different documents using different linking styles. Now you can have a unified linking style by creating templates for each of the linking styles in your documents. And then for each of those links, maybe you produce an RDF triple, which describes that link between one document and another. And then you have one way of navigating the links between those documents. And indeed, because you put it in RDF, it's very simple to navigate the links backwards as well, which is one of the promises of hypertext that the HTML never really kind of fulfilled. I think one of the big benefits here actually is something which I would say, well, I've tongue-in-cheek named no ETL, but we're not throwing away information here. This is lossless. Often when we move documents into a relational model, we lose information, but this doesn't throw away the document, and so nothing is lost. If you convert, say, 5 columns from a document, and then your project changes, and later on you need another 3 columns added, the documents are still there, you just add something to the template, and the information gets pulled out of the document and manifested into the table. This is something which in MarkLogic we call progressive enhancement, and we found that it really enhances the ability to build applications and to iterate those applications to be able to flexibly treat the data in this way. In addition, you've got the original document, so data provenance becomes simpler, because you know where the data has come from in that table. And something I'm calling data in context. In MarkLogic, those rows still know which document they came from, and those triples still know which document they came from. And you can fetch that document, given the row, you can fetch the document it came from, and you can pre-filter the tables to say, I only want rows from these documents. You can use that for provenance. You can use that, for instance, for temporal data that might stay in the document, but you may only want to view from a particular date, validity after this date or something like that. And importantly, you inherit the access controls of the source document. So whatever permissions you put on that source document apply to any generated data, so the rows and the triples, can't be seen if you can't see the document. And so there's no problems, therefore, with security leakage when you change between models. As a quick plug at the end, MarkLogic 9 is available as an early access release, but it's available publicly, and that's the URL for the website where you can go and do that. So if you're interested, you can go and try this feature now. And I'll leave the tag cloud of interesting things we've done in MarkLogic 9 on the screen whilst I take some questions.
So even if there is coffee outside already, we still have time for questions. 1, 2, 3.
Yeah. My understanding of what you said is that you regard the documents as the source, and the templates then declare in a way an equivalence of information. It's very interesting. But have you also thought about generalizing your approach? I could imagine templates which regard existing RDF triples as what is there, and then the templates brings into existence documents.
Yeah, so I think that's a really interesting concept. And what we've been working on top of what I've just shown you is this idea actually of delving further into entity relationship models. So there's a facility in MarkLogic 9 which allows you to define entities and relationships at a very high level, and that can be used currently to generate templates. Now, one of the things I'd really love to see in the future is that same entity relationship model enhanced with a little bit more information, which could maybe say, when you see this collection of RDF data, you make a document in this way, and the template is automatically generated that works on that document and produces the original RDF that was put into the system. I think that could be really powerful then in terms of managing your RDF data in terms of entities and kind of queryability of that. I think that could really enhance the product. So yeah, I'd love to do more work in that area, and I think we will.
I think that next question is from Gerd. Yeah.
Thanks, John. This is really exciting. But what about performance? Having suffered a lot the past couple of months, tuning on top to have a virtual. So I love the term no ETL, but virtualizing relational databases and doing Sparkle on them, suffered a lot from getting that really performing well. So do you have a view on that?
Well, I mean, this is a native feature. We're not aiming to compete with an RDBMS on speed, but we're also not doing a translation process into some other language and leaving it up to some other databases optimizer. So it's not like virtualizing. We have the triples and the rows are stored in purpose-made indexes in MarkLogic, and we have purpose-made optimizer and query runtime that will do the joins and the aggregation and things like that. So yeah, it's a different technology to virtualizing, another view over a database, because we're not doing it from outside a database. We've got access to the full internals of what MarkLogic is doing.
Okay, thanks. Sounds good.
Thank you. And there is a question from Florian, I suppose.
So you say you end up with data with the same permissions as the original document. Is that always the case, or can you use that mechanism to expose data with different permissions, because there's a use case as well to extract which data and control which data you want to expose with different permissions?
Yeah. No, so that is always the case. It's important to us that we don't have any security leakage. And so this kind of automatic extraction is going to keep the same security permissions. If you wanted to do what you were saying and have some data extracted which you would use under different permissions, you can still do that. We would just have to do the manual extraction and put it in the database under different permissions.
And so you need another fragment.
You would need to do that, yeah.
Okay, so I don't see more questions. So thank you again very much, John. And now there is coffee break, so it's the usual process as yesterday. So upstairs there is coffee, tea, and you can share with sponsors. Downstairs there are some snacks and something to drink. And also if somebody is leaving in the afternoon or just directly after the conference to home and would like to have taxi arranged for him, he can go or she can go to registration desk, and people there will arrange taxi for you if you are in such need. So enjoy the coffee.